Okay, I'm going to draw these graphs from the other day. You guys tell me, make sure that I have all these graphs drawn correctly. You got the first three. Are those correct? That's what you got? And then for this one, we've got something like that. We've got something like that. Something like that. Are you okay with that? So yesterday we drew the graphs. Today I want to talk about the domain and range, and then we're going to write a few functions. That's going to be it. Okay. So as you look at this function right here, this is something that needs to be stated. We want to talk about the domain, and wherever you have a little bit of room, you can just write this down. I think you wrote horizontal asymptotes there, but we want to identify the domain. Here's an easy thing for today. Domain for exponential functions, you can plug in anything you want and get a result. You can plug in negative numbers and get a result. You can plug in positive numbers and get a result. Plug in 0. So the domain is always negative infinity to positive infinity. And it's that way for all of them. Every single one. And if you get tired of writing it, you can just write quotes. Okay. Domain is positive or negative infinity to positive infinity every time. But the range is just a little bit different. Okay? Range are the numbers we can get out. So look at this first function here. Can you get out negative numbers? No. Can you get out 0? No. Very close to 0, but you can't get out 0. Can we get out numbers bigger than 0? Yes. So the range does not include 0, but starts at 0 and goes to infinity. Is this one the same or different? Same. You can't get out any values down here, so there's no negative numbers included. The horizontal asymptote goes right through 0. It never touches the horizontal asymptote, so we can't get 0, but you can get the numbers that are bigger than that. So the range is going to be from 0 to infinity as well. Letter C, same or different? Same. Range is going to be from negative or 0 to positive infinity. Okay. Let's change it up a little bit here for letter D. Okay. Is 0 the same or different? Yeah, it's different. Okay. Can you get out positive numbers for letter D? No, no positive numbers at all. Can you get out 0? No, very close to 0, but you can't actually get 0. Can you get out negative numbers? Yeah, so we're going to start down here. What number is way down here? So we're going to start at negative infinity, and we're going to go to 0, but we can't include the 0 because we don't quite reach that 0 spot. And then this graph right here. Can you get out numbers below negative 4? No. How about numbers above negative 4? Yes. Can you get out negative 4? No. So the range is going to be, we're going to start at 4, not including 4. I'm sorry, negative 4. And we're going to go from negative 4 to infinity. And then the range for the last one. Can we get out negative numbers? Can you get out 0? Can you get out 1/2? No. Can you get out 1? What number is bigger than 1? Yes. So the range is going to start at 1 and it's going to go to infinity, not including 1. So domain, always all real numbers for exponential functions. And the range is going to be, as we said, you're going to have to look at the graph. It depends on the horizontal asymptote. Grace, did you have a question? Yes, very good. So Grace makes an excellent observation. Here the horizontal asymptote is y equals 0. If you notice, that is one of the spots of the range. Here the horizontal asymptote was negative 4. That's one of the spots of the range. And here it's one of the spots as well. We can't always decide if it's going to be the first part of the range or the second part of the range. It depends on if the graph goes down or if it goes up. But yes, it will always be included. Always have a parenthesis on it. Okay. All right. Any other questions? Thoughts? Okay, let's look at example 2, A, B, C, and D. Here what we want to do is we want to find the exponential function that passes through the following points. And an exponential function has the form y equals some number a to the x power. So that's a base to the x power. So all we need to do for these problems is we need to find a. That's what we want to do. And once we can find a, we can write the exponential function. All of these problems are exponential functions that pass through what point? What point do they all share in common? 0, 1. Anything to the 0 power is equal to 1. So it doesn't matter what a is, you can see that they all pass through 0, 1, just like our graphs up above when we first started drawing them. Well, let's look at the second value, okay? Let's look at that. And what we're going to do is this is my y value, and this is my x value. And what we're going to do is we're going to, write an equation with those put in the place of x and y. So 25 is equal to a to the second power. Everybody see where I got that? I just use my function, I put in the x and the y values. So now there's no way to solve this other than just thinking about it right now, okay? What number do you square to get 25? So a is 5. So therefore my function is y equals 5 to the x power, and that's what I've got. Any thoughts? Questions? Let's do the next one. Now we have our y value is 2/3 is equal to a to the negative 1. What number? Question. Watch. Ready? 5 to the second power is 25. 5 to the 0 power is, so it fits both of them. Okay? It fits both of them. Okay? Well, anything to the 0 power is 1. So if I said, y equals a to the x, and you plugged in 1 for y, and you plugged in 0 for x, a could be 5, it could be 40, it could be 98. This doesn't actually tell us anything more than we just got an integer. The only number a couldn't be would be 0. So we're always the 0, 1, we could change it. We could make it 0, 2 and say then it was shifted up 1. So we could, say, put a +1 on the end of it. But that would change a lot of our approach. Okay. So what number do you take to the negative 1 power to get 2/3? 3 halves. Yeah, you would take to the negative 1 means you take the reciprocal. So a is equal to 3 halves. So my function will be y equals 3 halves to the x power. That is the equation that satisfies those points. It passes through both of those. Here we have our y value is 8 and our x value is 3. What number do you raise to the third power to get 8? 2. So if a is 2, then the function is y equals 2 to the x. And finally, the last one, 4 and 1/10,000. So my y value is 1/10,000 is equal to a to the 4th power. What number do you raise to the 4th power to get 1/10,000? Oh boy. 1/10. 1/10 times 1/10 is 1 over 100. Times 1/10 again is 1 over 1,000. Times 1/10 again is 1 over 10,000. So again, you got to kind of try to think through it, but 1/10 is going to be the result. So a is equal to 1/10. Therefore, my function is y equals 1/10, that quantity, to the x power. That makes sense? So before I give you guys your assignment, I just want you to see something that we're going to work towards, okay? if I gave you this, could you guys solve that and tell me what x is? Yeah. What's x? 2. But if I change it just a little bit, do you know what x is now? Do you have any idea how to solve for it? That's where this idea of logarithms come in. And so we're going to be solving exponential functions later on. So, you know how to solve this because you can mentally think through it because we're really good with integers. But this is a whole different scenario. So that's what we want to eventually try to be able to do. Okay? A little bit more challenging. So, but we'll make it easy because you guys are super smart. Okay, 4.1, page 344, numbers 9 through 26. Some of those are just matching. Some people got done last hour. That's it. So you do have some time to work. This class gets out at 1:39, so you've got about 9 minutes. I have not made copies of packets yet. The copy machine is still broken, and the one downstairs ran out of toner. I've had it up to here with copiers, but I'm taking a collection after school if you'd like to make a donation. Goodbye, YouTube. Cine, please wake up and pay attention for once.